So what are these X's and A's? What are these elements? And why do plants need them? Well, we need to define them in a broad sense, and we'll call these essential elements. You might hear the term also essential nutrients. What does it mean to be an essential element? Well, an element can be deemed to be essential to plant growth in one of two ways. And we call this a criteria for essentiality. Basically, the first way is to prove that the element is absolutely necessary for completion of a plant's life cycle. And so basically it means that the absence of the element in question prevents completion of the life cycle. What do we mean by life cycle of a plant? Well, life cycle of a plant starts basically with seed, and then you have the germination and you get vegetative growth. And then in the case of a flowering plant, you get flowering, and it goes right back into seed production. And if you don't have a second generation from this second round of seeds germinating, well, then the life cycle has not been completed. And so if the absence of this element in question stops this life cycle at any point in this process, it is therefore proven to be an essential element. The second way by which an element can be classified as being essential is if it has been proven or shown to be part of some essential molecule. And our more modern technology these days makes this a little bit easier to do than the old-fashioned way of proving that it prevents from a life cycle from being completed, is to do some chemical analysis on an essential molecule, such as, let me say here, a part of an essential molecule such as chlorophyll, or let's say sugar, or cellulose, which is what cell walls are made out of. So you can do this with modern technology through chemical analysis of various components of plants to show that an element may be essential. When we talk about essential elements, when they are in short supply to a plant, they can cause the plant to become sick. And we call this condition a nutrient deficiency. Now, nutrient deficiencies occur before the plant is going to just die outright for the lack of one of these elements. And the amount of deficiency that you can accept as a grower of plants or a manager of plants is going to be dependent on a number of factors. If you're a farmer, it's going to be how low can your yield be to where you can still make your desired profit. Well, that would be the point at which you'd want to try and do something about a deficiency. If you're in the turf or ornamental industry, deficiencies are not a good thing because it's affecting the main value of the plants that you grow, which is their aesthetic value or their visual appeal. When deficiencies become problematic for a plant, we can often see symptoms of this deficiency visually in terms of the plant's outward appearance. And where these deficiency symptoms occur is dependent on the element's mobility within the plant. So we've got, for example, plant mobile nutrients, and this means that the plant can recycle the element and move it to another location in the plant on an as-needed basis. And then we have within the plant nutrients that are considered to be immobile within the plant. And this means that the plant, once it's incorporated it into a substance, cannot break that substance down and free up that nutrient and transport it to another part of the plant. As an example, let's say we had a plant here, and let's say it's a, maybe it's a corn plant here, okay, and something like that. Our older leaves are on the bottom of the plant, okay, and our younger leaves are towards the top of the plant. One of the most common deficiency symptoms for a lot of our nutrients is yellowing, which we call chlorosis. Where it occurs first on the plant can tell us a lot about what element might be causing that condition, or which element is lacking. And this has to do with the mobility within the plant. So in the case of a nutrient that is plant mobile, its deficiency symptoms tend to occur in the older tissues first. And why is that? Well, let's take a look at our plant down here again. Again, our older tissues are towards the bottom of the plant. And a corn plant is in business in the first place to make sugars and to grow. And the leaves that are on the upper parts of the plant have a better chance of gaining more light because they're higher than maybe the surrounding plants. They also happen to be shading out some of these lower leaves. And so in terms of importance to the plant, the younger leaves are much more important to the plant's survival long term than are the older leaves. And so if we suddenly have a lack of a mobile nutrient like nitrogen, the plant will recycle as much nitrogen as it can from the older leaves so that the younger leaves, which are more valuable to it, are not going to suffer because of it. And so the yellowing that's caused by nitrogen deficiency would show up in these older leaves first because the nitrogen has been remobilized to the younger tissues. In the case of a plant immobile nutrient, the symptoms occur in the young tissues first. And that reason is once they are in the older tissues, they are stuck. They cannot be remobilized, and that's why we call them immobile. And they cannot be moved to the young tissues, even though the young tissues to the plant are more important and valuable than the older tissues are. And so that's something to keep in mind, particularly when you get into our other classes and we start talking about specific deficiency symptoms. It can help you discern between, let's say, maybe an iron deficiency and a nitrogen deficiency. To wrap it up, let's talk about the case of elements that are not essential to all plants, but that may be beneficial to certain plant species. And we call these beneficial elements. A beneficial element will not, in and of itself, prevent a plant from completing its life cycle if it's not present in great enough supply, but they typically will enhance a plant's ability to survive by somehow making them more competitive. And some examples of that are sodium, silica, and cobalt. We'll talk about sodium first. Sodium in some plants, particularly plants that are native to aquatic environments, can sometimes be substituted for potassium in osmoregulation. In other words, controlling the opening and closing of their guard cells. And silica is probably a better example to talk about in that silica is used by many plant species as a structural enhancer. Silica is basically glass, and glass at room temperatures and normal temperatures is rigid. It's solid. Glass is solid, and many plants use it for shoring up their strength of things like their flower stalks and making them more rigid. And anybody in the turf industry, commercial landscape maintenance, can tell you that they'd much rather mow St. Augustine grass than Bahia grass because the Bahia grass beats up and wears out their mower blades much more rapidly than St. Augustine will. And the reason is the Bahia grass, as you've probably seen, you may not be familiar with what it is now, but you've all seen it. It puts out these little seed heads, and they've got the little peace sign on the seed head, and they've got little black flecks on them. You'll just see them all through the summer putting out these seed heads. To be so tall, this stalk needs to be pretty rigid. and the Bahia grass makes it more rigid by having a greater amount of silica in that stalk. And the same holds true for zoysia grass, which has a lot of silica in their leaves. And so both of those turf grasses, because they're harder, because they contain this hard, solid mineral in them, makes it more difficult to mow. And so those are examples of beneficial elements. Again, will Bahia grass complete its life cycle without silica? Certainly, but it is more competitive with other plants in the environment if it has silica. And silica is never going to be deficient anyway. And a Bahia grass, because there's just tons of it in the soil. In fact, most of the soil is made out of silica compounds.